As you know, my name is Vikrant. I'm a senior staff engineer at SoFi, and previously I was at AWS working on S3 for close to 8 years. You all know S3 is a storage system, but S3 also need to deal with storing data in the sense that metadata, so you can index your data better. So that is where I think my experience of building NoSQL systems is coming into play here. Uh, yeah, that's something about me. And the last 2 years I've been working at SoFi as senior staff engineer. SoFi is a financial institution. It's a bank in the US, and we build a software using the cloud technologies, mostly AWS. All right, just before going to the talk, a lot of my content here is from DynamoDB book, the images, because I really love this book and I think everybody should read this book. The author Alex Debris is also a popular speaker as well. So I would like to credit some of the images that I steal from his book. All right, so I mean, this talk is about DynamoDB, but some of the concepts and some of the things that we're talking about here applies to any NoSQL system, whether it's Cassandra or any other NoSQL system. But let's assume that we're going to talk more about DynamoDB and less about Cassandra. But let's get started. So why DynamoDB, right? The first thing is it's serverless. That means you don't have to maintain any servers. DynamoDB provides you an API that you can talk to put your objects or rows, attributes, and you don't have to manage any of your servers. So that would be one of the advantage of using DynamoDB. It's serverless and it can scale elastically up and down. And the second one is no connection limits. I'm sure you have dealt with things like connection pools, JDBCs, and then you have multiple hosts hitting a single database, and you had to deal with connection problems. So the fun part with DynamoDB is there's no connection limits because of the way it runs on scale, runs on multiple partitions. You can spin up any number of hosts, whether it's on cloud, whether it's Lambda, on AWS or in Azure or Google Cloud, and then keep hitting without any connection limits from multiple hosts. And the scale, one of the biggest advantages is scale. So you don't have to worry about scaling your servers up, scaling your servers down. Everything is taken care by you automatically within the cloud by DynamoDB. And performance. So one of the things that DynamoDB provides you is consistent performance. So think about the image that you have here, right? So if you have your MySQL or Postgres database, you start with some database with very small amount of data when you build your application, let's say 1 GB, and it's super fast. It works really well in your pre-prod environments, production environments. But as you grow, you can see the performance keeps going down, and the curve keeps going into fast, sluggish, and painful. So at that point, all you need to do is probably hire experts and manage your indexes, and maybe have to do some re-architectures and stuff like that to come back to a normal state. But that's a lot of effort, right? And you need to have expertise in something like you see a lot of database administrators doing that kind of work. So with DynamoDB, you get this consistent performance. It's always fast. You do it once on 1 GB, and you can scale it until 1 TB or even 10 TB, 20 TB, even petabytes. You can just keep having the same performance, a consistent performance. And consistency in the sense of performance as well, but consistency in the sense of NoSQL database as well. So you see a lot of databases or a lot of NoSQL databases, because they have to manage replication. You also want you don't get consistent responses back, in the sense that most of them are eventually consistent. Like once you write your data, you read it, you might not get the latest data. You might get a stale data, right? So DynamoDB gives you read after write consistency. That means once you write, you can get it immediately if you can call your master replica. It also supports both eventual consistency and strong consistency, but let's talk about that later. But consistency is something DynamoDB provides. And predictable billing. So because of the way things are in the cloud, you just can do a capacity planning or request planning and decide this is my monthly billing going to look like based on my growth. So it's very predictable in that sense. And zero downtime. Yes, DynamoDB had few outages here and there, but most of the time it's zero downtime. So remember how many times you had to deal with your database admins to say, you know what, we're doing an upgrade, and you'll have a downtime, and you'll have to have a downtime with your customers. You send an email to customers or have some banners in your home pages saying we are down for maintenance. With DynamoDB, you don't have to do that now because it's always up. Okay, let's go to the next slide. So before we go in detail, so one of the guiding principle of DynamoDB is it won't let you do things that won't scale. So with your data modeling, you won't do things that you cannot scale. Well, and unlike a relational, there are no joins, no filters. You can't do sums, no aggregations. So how do you do data modeling then? So let's get to that. Okay, before going in deep, let's go into some NoSQL concepts. You have your primary key, just like relational. You have a primary key, but the primary key consists of a partition key and a sort key, which is a composite primary key. You can either have just a partition key without a sort key, or you need both. You can do with a sort key, with a partition key and a sort key. So in this case, look at the image. You can see Tom Hanks as partition key, and some of his movies like Castaway, Toy Stories, or for example, or your sort keys. But you can get away with not having a sort key altogether as well. Or you can have a composite primary key, just like the image. And the attributes, we have something called attributes here. So you have roles, years, and genres. So those are the attribute fields. And unlike relational, these are called items. So you call them rows, but these are items in DynamoDB. And one caveat is you cannot query with attributes. So you cannot have you can query DynamoDB with partition key and a sort key, or a partition key, or a partial sort key and partition key, but not an attribute. There are indexes, just like relational DynamoDB supports, they're called global second indexes. We're going to talk about them later. But without setting up a GSI or a global second index, you cannot query with attributes. All right, so how does DynamoDB work? I'm sure you know a relational database is, let's say, is running on a single host, but unlike that, DynamoDB works on partitions, and partitions are working on running on different hosts. So let's say one partition is associated with one host. So let's say there are 9 hosts in this case, where each partition lives on, and let's say there is we spoke about partition keys and sort keys. So let's say the partition key is a customer ID and the sort key is order ID. So when DynamoDB web server receives this request to its request router, so the request router looks at the customer ID and figures and does a hash and figures, I need to go to partition 1 where this item belongs to, and do a put or a get. So that's how DynamoDB internally works, where there's a hash, and then the hash, based on the hash, you go to a single partition and do a fetch or a put. But partition 1 is also replicated into multiple other hosts, so that way you don't you get that durability and also eventual consistency, and you can hit any partition to get your data. So let's look at some first order things for your data modeling. Generally, what you do is you go draw an entity relationship diagram, correct, in any data modeling scenario. You have to do the same. You build your relationship diagram and then write up your access patterns. So some of the access patterns can be, hey, look up your employee details by employee ID, or query employee details by employee name. So write them down in Excel or Google Sheets or whatever. And then think about what should be your partition key. That partition key would be able to help you to shard your data, and think about what can be your sort key. The sort key can be used for sorting your data in order, so you can preserve the orders, for example. And also, what can be your indexes? In this case, let's say you want to have in the previous in your previous image, let's say you want to have year as one of your index. So decide on your global second indexes as well. So some of the things that you have to think about when you're thinking about data modeling, these are the first order things. And these are very similar to what we do in relational as well, except you have a primary key, but you have a partition key and a sort key here. But the second order is the most important part, because these are some things that post or enforced by DynamoDB. So some of the things I need to know is there are conditional expressions that you can write in DynamoDB. Put if, so you can do things like, hey, put this object only if this condition is true. So you can write conditional queries. And DynamoDB also supports transactions. So like just like relational, you can also think about transactions in the sense, if you have three queries to execute, so you can wrap it up in a transaction, and DynamoDB make sure these are atomic, so that way all the transactions execute or none of them execute. And you can also think about complex attributes. So I know we know we have things like binary data, etc., in your databases. Uh, Along with that, DynamoDB also have complex attributes. That means there's something like maps and also lists that you can support. If you look at the image, the mailing address, for example, I think is a map, and this is one of the complex attributes that you can write. And but you cannot write GSIs and complex attributes because it's hard. But your GSIs can be on your first name and last name in this image, for example. And DynamoDB also has some limits. So any query or scan operation that you're doing against DynamoDB is maximum 1 MB of size. So if you write something, you cannot get back more than 1 MB. You need to think about pagination and stuff like that to keep your previous marker and then query again, so you can read or scan your full database or query your full database if you have to. And DynamoDB has something called partitions, as we talked about, and there are limits on partitions as well. The current limits are around 1K, 1,000 write capacity units and 3,000 read capacity units. These should be pretty much should be very high number for most of the applications. But again, if you are thinking you need more, then probably you can need to go towards on-demand mode, or think about what mistakes you made in your data modeling, because generally they should be pretty sufficient, because 1,000 TPS and 3,000 TPS per second should be sufficient in most of the use cases. And the row size is 400 KB. So whether you use complex attributes, whether you use normal attributes, you cannot have more than 400 KB. So that is something that you have to think about when you're modeling your data. And the maximum partition size is 10 terabytes. So imagine as I said, we have a partition key, and the partition key would be going to one host. So you cannot have, if you model your data such a way that all your data is in a single partition key, then you're doing something wrong, because the maximum partition size is 10 terabytes. So you need to find some high cardinality attributes for your partition, so you can divide it better and you don't hit this limit of 10 terabytes as you grow. Okay, so we already spoke about some primary key, but let's go into more detail. So primary key is a unique key that combines both partition key and a sort key. So it's always unique. For example, if you have like Amazon and the date here, which is 1824, if you write again, you're going to overwrite it, and it's not going to be a new entry, but you're going to overwrite. So it's always unique in the sense that partition key and sort key is always unique. And you cannot update a primary key in the sense that you can only overwrite it, and every new write of partition key sort key is a new row or item in DynamoDB. And partition keys for grouping, as I said, partition key is used in hash, so you can hit the right host or partition in DynamoDB. So it's used for grouping your data together. And sort keys for ordering. So if you see on the side, you see the sort keys are ordered lexicographically. And partition key should be selected with high cardinality, so that way it's always unique, and you always hit multiple partitions and not a single partition. As I said, if you hit multiple partitions, you get more throughput out of your partition than being restricted to 1,000, 3,000 TPS that DynamoDB imposes. And you can also, some strategies while developing your partition key is high cardinality. You also need to think about composite attributes. So if you look at the image there, the invoice number, let's say, is 121212, these are composite attributes in the sense there's something called hashes that we are using in this case to create more high cardinality partition keys. So you can employ that strategy in your use case. And also you can add some predictable randomness. So let's say you have that invoice number, but you want to also create more partition keys. Then you can add some kind of randomness between, let's say, 0 to n, hash your data, let's say hash your one of your attribute, and decide where you want to go into your partition key. So it's not easy for search, but if you want, you can employ that strategy based on the use case. Again, I wouldn't recommend it, but if your use case permits it and you don't have an option, then you can do something like predictable randomness as well. So you can go into multiple, go and hit multiple partitions and not just single partition. And some of the best practices of sort key is you can also, just like partition key, you can also have composite sort keys where you can do on hashes, just like how you have your client one txid hash one, client one txid hash two. So you can do composite sort keys as well. And the nice part about sort keys, you can do, if you want to query, you can get your partition key and then say starts with something in your query, so that way you can list everything from your partition. And sort keys can be used for versioning. So let's say you have to you have some use case where you want to update the data. You have a lot of updates coming into one of the use cases, but at the same time you want to preserve the history. Then you can use sort key as your versioning strategy. That means every time you get a new version, you update it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Such a way you can have that history on using a sort key. And you can also employ things like sorting with timestamps. Like, hey, every time update comes in or data comes in, you can create a UUID. Sorry, you can create a timestamp, epoch timestamp, or ISO 8601 date, and then add your data. So you can use that for sorting. And you can also use UUIDs. But with UUIDs, what happens is you lose the order. So for that, and the previous one where you can have timestamps that are colliding, if you're dealing with high scale, then you would have some collisions. So there's something called ULIT that you can also try out, so that you get both, best of both, which is best of UUIDs and also sorting with your timestamps. So the advantage of ULIT is it preserves your order. The way ULIT works is the first 48 bits is milliseconds, so that way that the 48 bits make sure they're ordered, and the next 80 bits is make sure they are random. So that way you still get randomness and not have collisions with your timestamps if you're using timestamps. And the URL safe and also lexicographically sortable, as I said. Okay, let's get to queries. So you can write queries on your database, on DynamoDB database, and for that you need a partition key. Let's say in this case, a partition key is device 123, and if you query by device 123, you're going to get all the readings, as I said, reading from the beginning, and maximum you can get is 1 MB, and you'll have your last token, and based on the token you can query again and fetch that full data for device 123 partition key. And I also said you can have a sort key in your query, or you cannot have it. So you can also do something like partial sort keys. For example, you can query, hey, my partition key is device 123, and my sort key starts with reading 2020-03-1410, let's say. So it's going to give you all the readings that starts with reading 2020-03-1410, for example. So you can do a full partition key, or you can do a partial sort key, so you can get a list of all your readings in this case. And you can also add some filters. Filters are like very small things, like, hey, I want to have temperature greater than 32.1, for example. So you could add those filters in your queries, and DynamoDB does that filtering, but still you get back 1 MB of your data. And I really like this feature, which is scan index forward. So a lot of times when you design, you think, oh, maybe I have to always go from top to down. But DynamoDB also supports something called scan index forward. You can set that field to false, and DynamoDB can return you from top down as well. In this case, you can get, if you see the image, you can get the readings in reverse as well. So that is something that DynamoDB offers, which is pretty nice. And pagination, as I said, because DynamoDB has these limits of 1 megabyte per query, you need to DynamoDB supports, or DynamoDB SDK supports pagination by out of box. So you can get your last token and then query again, and then fetch those readings, in this case of device 123. And you can also do consistent reads. DynamoDB, as I said, can support read after write. By default, it's eventually consistent. So you have to set, when you're writing a query, you have to say, I want consistent reads. When you say consistent reads, it's going to hit the master node and get you the data, not the slave nodes. So that way you always have that read after write guarantee. And favor query over scan. So queries will need partition keys. So having post partition keys is easy to fetch your data. Scanning is bad because you'll have to go through a lot of data, and if you have terabytes of data, then it's going to take forever. So always think to query your data over scanning. Okay, so let's get to an example of one-to-many relationships. So a lot of times you have to data model on one-to-many relationships, like customer has orders, for example. That is one example. Or actor works in movies, so that is, or has a bunch of movies under his bucket. So that is one-to-many relationships. So how do I fetch the information about customer if I have an order, right? So some of the strategies that you can employ are denormalization, which is exactly opposite of normalization that we do in relational. And you can also employ strategies like pre-joining your data, so that way they are co-located together in DynamoDB. So let's get through some examples and see how that works out. So so if you see, so sorry, I think the image has got the title, but what I'm trying to say here is, so let's say you have an access pattern where you want to do one-to-many relationships, and let's say a company has few payment methods, and the payment methods in this case are a credit card and a bank account. So what you can do is you can create a complex attribute in DynamoDB, and so if you see here Berkshire has a partition key, and Berkshire has two payment methods, which is credit card and a bank account. Same thing with Facebook. Facebook has a credit card and a bank account as well. So one organization has multiple payment types. So you can employ something like a complex attributes, like a map that we described, and denormalize your data like this. There are a few caveats with this, that you cannot have indexes. As I said, you don't need an access pattern like, hey, get me all credit card numbers. I don't think you'll have it. Or get me all bank accounts. You'll probably go by employer in this case. So if you have a reasonable use case, you could employ this denormalization plus complex attribute as one of your idea. But at the same time, we also have constraints like 400 kilobytes on a row in DynamoDB, correct? So this strategy cannot be applied to, let's say, things like customer has orders. If the customer is ordering hundreds of orders every day, so this won't work, because you're gonna exhaust your row size or item size. So let's look at other strategy for that. So another strategy is to denormalize your data, but also duplicate your data. For example, in this case, you have Stephen King as one of your author, and you have few attributes. Let's say author birth rate is something that you want to get every time, and or you have a book name and you want to fetch the author birth date based on it. Author birth rate is generally doesn't change. Once you have it, and you don't really change it. So what you can do is you can duplicate the data, and you don't deal with any data indicate issues because the data doesn't change. So this is something that can be applied, data duplication and denormalization, if you have no data integrity issues. And other strategy is pre-joining your data. When you pre-join your data, you have a complex composite primary key plus queries. So as I said, remember, we can co-locate the data. For example, you can data model in the sense you have a Berkshire Hathaway as a partition key, and you have a Berkshire organization item followed by user items in the same partition key. So what you can do here is you can co-locate the data. When you co-locate the data, when you fetch your when you write a query for give me user items, for example, of Berkshire, you can do a query on Berkshire, and you're going to get the organization item and also user items. And based on the organization items, you can get information about your organization. So user items are, in this case, organization to user items is one-to-many. So whenever you fetch a user items, you can also get the organization items directly. So you can employ that strategy for one of the strategy for one-to-many relationships. And next concept is filtering. And a lot of times you'll have to filter your data, right? So you can filter first of all by partition key. That's a very basic thing, but you can also apply some advanced filtering strategies. again, filtering by partition key and sort key is basic because we know those are the primary filtering mechanisms. But you can also do something like sparse index. Sparse index is an interesting concept. So, for example, if you look at the diagram here, let's say you want to create a GSI, which is a global secondary index on one of your item. So what really happens? Maybe this is a better example. So for example, in this case, you create a GSI PK and SK on the book name, and or maybe this is not a better example. Let me see how to bit. Yeah, I think this is a better example maybe. So let's say Berkshire has like users, and one of them is admin. Like every organization has an admin user, and you want to fetch all the admins, for example. So what you can do is you can create a GSI primary partition key one and GSI sort key one on your item. So that way, when you want to fetch all your admins from one place or all your admins, you can fetch them with this. So this is a sparse index because if you have thousands of uh, people or thousands of employees in Berkshire, let's say there is only one admin, and every company has their own admin in this case. So by writing a GSI PK and SK, you're creating a sparse index. So that way you're when you so maybe I have to take a step back. So when you do a when you create a GSI, DynamoDB is actually creating a new table for you. So in this case, there's another table that is created with the partition key as the company name and the sort key as admin. So you can query by, hey, give me the admin for this company, for example. So you can get the sparse index, which is admin directly. And so you can filter by type, as I said, on admin type, or you can also query by single attribute into the index. And another filtering strategy that can employ is always you don't have to rely on server-side filtering. You can also employ client-side filtering. That means you can fetch 1 MB of your data from DynamoDB and maybe filter it and keeps your data for maybe for other things. Maybe you're doing things like storing your data and then using it your next page. So you can also employ client-side filtering. I think one strategy that we did not go in deep is global secondary index. I was hinting about it all over the slides, but let's go into this as well. So in DynamoDB, so you have two kinds of indexes that DynamoDB supports. One is local index, another is global secondary index. I wouldn't pay too much attention to local index because local index is only for partition, whereas global second index is for all your partitions. So I would focus on global second index here. And the way global second index works is when you create your table, you can set up, I want a secondary index or a global secondary index. Let's say you define your organizations, in this case organization, and sort key is Berkshire Hathaway. So DynamoDB underneath creates a new table for it. So every time you make an update to your table, DynamoDB also makes an update to your index table. But one caveat with index, GSI or global secondary index, is you cannot get consistent reads on your index table. So make sure you work around that because you won't get what you get is eventual consistency indexes and not a strong consistency. So that is something that you have to work around. There's a limit on GSIs today that I believe it's 20, so you can have 20 GSIs. So make sure you are thinking about that problem as well and not create an index for every attribute. And one more thing is every time, because DynamoDB creates these tables, so the cost also increases because every time you create index, you're writing to a new table. So what you can do is you don't have to pick the full row information. You can say, I only want organizations and for example, the company name as my primary key and sort key. And I only want, let's say, subscription level. I really don't care about organization name or organization address, for example. So you could also pick your data into your GSI so you can save some cost in that. Yeah, and we spoke about sparse indexes. Sparse indexes are data or tables or indexes that have smaller amount of data, so you can pick your filters or write your filters with it. I think we also went through this, which is a sparse index where you have an admin. So if you, I mean, maybe this is a good example. So how does other table looks like when the, how does a GSI table look like? So when you write to your primary table, GSI creates another table. So this is how it will look like. You have your partition key, sort key, and the full attributes in this case. But again, you can pick your data when you're defining your data, when you're defining your models. All right. I think we covered most of it. Thanks for joining. Let's go through it.